Okay, so let's start where we left off yesterday. I think we discussed the theory behind our decision tree algorithm, and let's continue now with the practical implementation. Okay, for the same purpose, let me import pandas as a PD, right? Perfect. My Titanic data set, suppose, because it's a classification problem, and let me check. Okay, df.head. Same thing is there. Okay, with it, we will implement it in 5 to 10 minutes, not more than that. It will not take time more than that, right? So we know that, or we have already seen this data several times. So what we can conclude from this, now you people can tell me, everyone, please, you have seen two implementations. So now you people can help me out in implementing the algorithm. That will be your learning as well. Okay. So can you tell me which is the output column here? First of all, you've seen the same data, everyone. Come on.
Survived.
Very good. Very good. So we can say that survived column is output column or target column, right? Perfect. Okay. Next. It's a classification task or it's a regression task. We can see at the data set itself, it's 0, 1, 0, 0. Only distinct values are available here too. Okay, and how can we verify?
Classification.
Yes, how can we verify it has only two distinct values? What we can use? We can
And
use.
unique. And unique.
Yes,
Or
yes, very good. Or
count values.
yes, yes. We can do both the things. Survived dot and unique. Okay, this will give me the two unique values are there. Okay, so this is what? This is your classification task. This is your classification task. Perfect. Okay. Next step, what we should do, mandatory step that we have to do is what? We have to check whether how many rows are there, how many columns are there. So what is that? df dot shape. We have in total 887 rows and 8 columns. Perfect. Let me check their corresponding data types. How can we go that? df dot info. If we execute this, we can come across, we have integer, object means your text data. Okay, object means your text data. Two object columns are there, rest all are numeric columns. Very good. And if you observe properly from here itself, I can know in total there were 887 rows. It is showing 887 not null, 887 not null, 887 not null, right? So nowhere there is lesser number of rows. Everywhere there is an equal number of rows available. That means 100% there are no missing values. But let's verify that, no problem. So how can we verify our missing values? By using df dot is null, then dot sum. Okay, so we see that in every column we don't have any missing values. Okay, so at least one of the work that we may require is not available here. All are all nothing, no missing values are there. Perfect. Next step, everyone, can anyone tell me, please? All the mandatory steps that we have to do.
Removing columns which have unique values.
Yes.
So we will remove name
Do we have
column.
any? Yes, we have a column, name column. It makes no sense, so we can remove this column. So how can we remove that column? By using df dot
Df dot
drop.
drop
Okay, column name is what? Name. And we have to
name
mention
x
here
is equal
what?
to 1.
X is equal to 1. And one more thing, in place equals
In
to
place equal to true.
2. Okay, let me execute this, done. And let's check again. df dot head. Okay, we should not have any column available now known as name column. Perfect. The next step, everyone, what do you need to do? Mandatory step I'm asking.
One hot encoding
Yes,
on
for on sex column, right?
sex column.
Because there should be no numeric, all the columns should be numeric column. All the columns should be numeric column. So we see that this column is a text column. We need to convert into the numeric column, but we see here it's a nominal data. Okay, it's a nominal data. So we have to do one hot encoding. So how can we do one hot encoding? Which method is there? pd dot get underscore dummies method, in which we'll pass our data frame, and also we'll pass one more argument, drop underscore first equals to true. If I don't mention that, I will get two columns, one corresponding to male, one corresponding to female. But if I use drop first is equal to true, I will get only one column. Okay, so that this will be my new df. So execute this and check now. df dot head. Okay, everyone, can you observe now? Everything is suitable for your machine learning model. It's model. Lots of optimization you can do. That's a different task. But your basic algorithm, which is ready for machine learning, is available here. Your recipe is ready so that you can prepare cake. How the cake will be prepared, that depends on how much hard work you do in a data visualization. You understand every pattern. Okay, what can we do? What is the better thing? That is your basic preparation. But how much better preparation you do before put the data to the cook? Okay, before that, how much effort you do, but basic ingredients is ready to do. Okay, so suppose I want to build my data on the basis of this. So what should I do next step? Remember, we have to separate our output variable and input variable, right everyone? Output variable and input variable. Two mandatory things are there. First of all, no missing value should be there. There should be no text column available. All the basic thing we have done. That was the basic thing which was required. Done perfectly, right? And remember, it's which kind of data? It's algorithm is probability based algorithm, right? Entropy based. Okay, where everywhere probability was using, nowhere distance was calculated. Nowhere, right? So we don't need of doing any kind of scaling here. For this algorithm, there is no any need of uh, doing the scaling, not even required, because this is a probability based algorithm. Okay, so no need of that doing that. Okay, earlier we did in the naive base, because your theories, the naive base says when you are using Gaussian NB, they love the data to be in the normal distribution. But I think we experimented that and we saw that there was no impact of scaling on the algorithm. So result were coming same. I think you remember everyone. We verified that with the scaling and without scaling even in the last class. The naive base were giving the same result. Can you recall? Yes, Varun, right? I think Hardik told me to verify that and we verified that, right? With the scaling data and the non-scaling data, everything was giving us the same result. So no effect. Same way, no need of doing any scaling. No need of doing the scaling. So we have to separate our output variable from the input variable. How can we separate? Come on, everyone. I'm waiting for the answers. Separate survive column and make it a y variable. Rest of the columns to be your input variable. How can I
We
mention?
will we will drop the survive column from
Yes,
the
x
main
is equal to
column
df dot
with
drop.
X.
Okay, and here column name is what? Survived, and here x is equal to 1. Should I mention here in place is equal to true? Tell me.
No.
No, very good. Very good. Awesome. Right? Because what will happen otherwise, you will not be able to get your df column. Right? So no need of doing that. So your survive column. It is sufficient. Now here mention, just mention y is equal to df, because we needed it. Although these square brackets are not mandatory, in within one square bracket, I can put my column name, but it will give me an array this time. Okay, but I want a data frame. That's why I'm putting square bracket. And I here mention my column name. That is your survived column. Execute. Done. And let's verify once again. X dot head. Okay, we don't have any survived column. P class, AJ, siblings, parent, children, fair, sex, male. Done. And we have our y dot head. Okay, only one column, survive column. Awesome. Now it's time for what? Your data is ready. You need to split your data into training and testing. For that, which library will import? From sklearn dot model selection. Okay, import train test split. Okay, you don't need to remember the complete name. You just know the basic. Just type first letter, press tab. Automatically, will give you the hint. Okay, you don't need to memorize. Then we know that. How will we use it? Train test split. What need to pass here? X, Y. Then we need to pass here a test size. Okay, suppose 0.2. We need to pass here a random state, suppose 42. And as it's a classification problem, we should pass here one more parameter known as stratify. Okay, stratify is equal to what? On the basis of which you are deciding on the basis of the y column, which is a survived column, so that in training and test data equal proportion, the same proportion goes which is available in the original data. Okay, suppose in the original data you have 70% survived and 30% unsurvived, so same proportion should be maintained in the training and testing data. Okay, so same thing we are mentioning means stratification, stratified sampling you are want to use, but according to which column? That column is your y column. Right? I just mentioned here, and we know that it will return us 4 parameter. Can anyone tell me what is the first parameter? X underscore train, then X underscore test, then Y underscore train, and then Y underscore test. Right? Let me execute this. Done. And let's verify. X underscore train dot head. Let's see. Okay, let's check the shape. That is better. 709. Okay. X underscore test dot shape 178.6. Perfect. And again, Y underscore train dot head. Okay, fine. I want to check actually shape. Okay, sorry, 2 dots I put. 709. Okay, same should be there. That's what I want to verify. Same is there. Awesome. And similarly, let me move it up first. That is better. And similarly, Y test dot shape. It should be 170. Perfect. They have been perfect. Next step, everyone. So my data is separate. Now what I need to do? I am asking you people because so that whenever now you become familiar, third algorithm we are typing, everyone, right? Third algorithm we are typing. So now you should be comfortable. What step should be next? So we have our training and test data split. Now what you need to do?
Scaling.
I told you scaling. Yes, the step should be scaling, but is it necessary in this case? No. Right? I can mention here, no need of scaling as it is not distance-based algorithm. Right? No need. Don't do this. No problem. If you want to do, even do, no problem. No effect is going to be happening. 80-20 we have done already. See, already done. Varun, we already did that, right? Already our training and testing is that way only. Right? We already mentioned. Now what we need to do, if we don't need any scaling, we can directly import what? My machine learning algorithm. Okay, so I'm going to say from sklearn dot tree import decision tree classifier, because it's a classification problem. If it would have been regression problem, what we have called? Regressor. Clear, everyone? When it's a classification, we'll call it classifier. When it's a regression problem, we'll call it as a regressor. It's a classification problem. Just use this, execute that. Come here, okay? And it's a class to create an object of the same model equals to decision tree classifier. Okay, create an object of the same, right? It has few parameters. We'll discuss about them. Okay, can you see, everyone? There is one important thing here. Criteria. Can you see what is mentioned? Please observe this one. Guinea, right? Means by default what it is using? Guinea, but you can change it as per your requirement. You can make it what? Remember what was our criteria? Entropy one. So instead of Guinea, I can mention this like example. I can mention this criteria equals to what? Entropy. But you will be saying, sir, how you come to know here only Guinea was mentioned? So what you should do, understand, everyone, all the time, whenever using any machine learning algorithm, it is impossible to remember all the hyperparameters of any machine learning algorithms. There are so many. Example, if I press here, there are so many parameters. See, you will not be able to remember these. So whatever, whenever you are implementing any machine learning algorithm, always go to the Google and type hyperparameter of decision tree like this. Okay, so go to the site of scikit-learn because it's the original site. And here see what are the options available. Criteria is Guinea, entropy, and there is one more option known as log loss. Recently they have introduced, earlier it was not there, and default is what? Guinea. Okay, Guinea. So from this you can come to know, okay, what are the different arguments that I can put? I can put Guinea, I can put entropy, or I can put log loss. Right? Different parameters are there. So always read, okay, what can be done with the help of, I will show you, just let me implement and I will try to show you with the help of these parameter, I can improve the performance even. I'll show you that within few minutes only, okay? So suppose I mention criteria is equal to entropy. For now, only one parameter I change and rest are the default parameters. I'm not changing anything. Whatever they have decided earlier, the rest of the formulas are, rest of the things are default. I'm not going to change them. Example, execute this. So my instance or object of the decision tree classifier has been created. Now it's time to fit my model. And we always fit on the which data, everyone? Training data. So what I will mention? X underscore train, Y underscore train. Here it will learn my algorithm. Okay, my learning phase will begin and it will train my machine learning model. Let me execute this. It has been trained. Awesome. Now we can use for the prediction. Suppose I said that from this model, I have a method known as predict. Okay, what I want to predict, I want to predict the value of y test from the x test. Okay, unseen data we are passing. Remember, this is unseen. My model has been trained only on the training data. We kept intentionally some unseen data, which was what? X test. Okay, so that we can check how my model is performing. So I'm giving it unseen data and let's check how well it is performing. Okay, so suppose this is y pred equal to this. Let me execute this. So we get some results. Perfect. Let me check y pred example. Okay, it is giving some 0, 1, 0, 1. Perfect. This is what we want, but how accurate it is, I don't know. How well my model is performing. How is it good? So I have to import some matrices here. So I'm going to say from sklearn dot matrix import. I'm going to import few more parameters this time, everyone. Import accuracy score is a one parameter. Precision, come on. Precision score is one parameter. Recall is one parameter. Confusion matrix is one parameter. These all are what? Remember, these all are your performance matrices. We have just discussed accuracy score so far. Today we will discuss these as well. And you can use it in any algorithm because at that time we was running short of the time. That's why we only discussed accuracy score when we were implementing thing, I think using naive-Bayes algorithm. Okay, we were short of time. Now we have a time, so we'll discuss everything. So these matrices, whatever I'm discussing, you can use in any classification algorithm, right? And a classification report like this. Let me execute this time. Okay, and let me import first of all just one accuracy score. Accuracy score. For it needs every of these, you will see they will need two arguments: y true and y pred. Y true and y pred. Y true means actual value of y. Okay, so actual value of y test is x test. The y test is what? Y test. This is the actual value which you have kept. Remember this one. Y test. This is the actual value which you have kept separate. Okay, and you will compare this with the predicted value of the y test. Okay, this is giving me predicted value of the y test, right? We passed our x test and I asked him, please predict it my y test. It predicted that. So what is the, how much accurate it is? Y pred. Let me execute this. How much accuracy we are obtaining? 73.03%, right? 73.03% is, it is on the test data, but it is on test data. Now let me come here. Let me check how well it is performing on the training data. So I'm going to mention here accuracy score again. Can you tell me, everyone, this time, what should I do if I want to check my accuracy on the training data? Come on, please tell me, because everything cannot be spoon feed. You have to understand by your own itself. Tell me, what should I do if I want to check my training accuracy as well? What do you mean by training accuracy? Is it clear? Training accuracy means check how well it is doing even on the training data. Means just pass your training data and check how well it is doing on the training data. The data from which it is learned, passed as an input for prediction, and check. Example like this. You in the class you explain, no, not on test data. No, understand what I'm saying. In the class I taught you something. Okay, in class I taught you something and I explained you few questions. Okay, from that questions you did the practice, then and in the exam I gave you same questions which I explained you in the class, exactly same questions. Okay, this is what I am giving you, same data which I use while training you for the testing purpose. I explained you 10 questions in the class and then I'm giving you same 10 questions. Among that 10 questions, please tell me, and I want to check how well you have trained. That is what you're training. Okay, you're testing on the training data. So I want to calculate my training accuracy. How will I get my training accuracy? Training accuracy will you test on the training data only. Okay, so what I have to do is time. I have to predict what y pred train. Suppose I want to predict y train, but from my model. So model dot predict what y train from which x train. This will tell me what training accuracy. This will tell me training. I'll put the train, not the training accuracy. It's what? It's your training. Means you are predicting the value of y train. Means what we are doing here, predicting y train from x train. Okay, but remember, this data that you are seeing right now, which we are passing for the prediction, is not a new data. On this data only my machine learning model is learned. Only on the same data. See, we have passed that. When we fitted our data, which data we passed inside? X train and Y train. So my model is learning from the same. Okay, very much like I tell you now, in the classes, I explained you some example to explain something. Okay, and when I conducted your assessment, I give you the same question. Let me tell how well you are performing on the same. How well you are performing on the same. This is what training phase. I'm checking your training accuracy. I'm giving you same questions, right? So what is happening? I'm giving you learned from this, and I'm giving you same data. Okay, now check. Now check, even I'm giving the same data, how well you are performing. Okay, so I'm checking its Y value. No, that's the thing. That's okay. Let me execute this. See, execute, right? And now let me check what needs Y true. What is the Y true? This in this case, everyone, Y train. The actual value is Y train, and predicted is Y pred train. Let me execute this. See accuracy, everyone. What is the accuracy?
0.98448.
Means how much we can say in terms of percentage? 98.44%.
98%.
98.44%, right? So this is your training accuracy that you are seeing right now, right? And this was what? This was your test accuracy, because what we did, we passed unseen data to the model. And I said, okay, these are the unknown questions. Okay, means something I explained you in the class. I explained you 10 questions. On the basis of them, I created new questions. Okay, but those questions were never visible to you in the class because I explained you the concepts. Then after understanding the concept, I'm giving you the questions. Okay, but questions are conceptual, not the same question that I've explained in the class. So I give that. On the basis of that, your performance is being checked. So this is actually the true reflection of your model. How well your model is performing, not this. If your model is performing 98% on the training data, okay, and bad on the test data, and you present this in your organization will kick you out next day. Move out. You don't know machine learning. Get out of the class. You are like a chatur from Three Idiot. Why? You memorize everything. That's what is happening here, right? On training data, how much accuracy it is giving? 98.44. Very good accuracy. But on test data, see, performance is not good, right or wrong? Huge difference, 25% difference. Can you see, everyone? When your model performs very good on the training data, but not good on the test data, this process is known as overfitting. Remember, this process is known as overfitting. What do you mean by, I'm repeating once again. What happens, understand, when your model performs good on the training data, but not good on the test data, means your machine learning model, your performance is good on for training data, it's good, but for test data, it is bad. Then such kind of model is known as, my model is overfitting. It is memorizing everything from the training data. That's why it is doing what? That means if this is the case, it is like Chatur from Three Idiot. Have you seen Three Idiot, everyone? Have you seen the Three Idiot movie, everyone?
Yes, sir. Everybody
Like,
sees.
oh, no,
Everybody's seen that.
actually, I don't know because at that time I was in 2007, I think it's released, 7 or 8. Okay, it was way back. That's why I asked you. At that time, you must be very younger. I don't know. That's why I asked you. It was really released in 2007 or 8, if I am correct. It was that time I was doing my Amtech. That's why I asked you, right? So see, what is that? It is like a chatur. Memorize everything. Memorize, right? Memorize. That's why when unseen data is giving, test data is what? Unseen data. Okay. When unseen data is doing, what is performing? Bad. Okay, so when your performance is good on the training data but bad on the testing data, I will say what? My model is what? My model is overfitting. And that's what is, this is the problem with the decision tree. Decision tree algorithm easily overfit. This is the drawback of decision tree. It does overfitting. Can you see the difference, everyone? Accuracy, training accuracy is almost 100%, 98.4. Okay, if we right, and testing accuracy is 73%. This is the drawback of the decision tree, but we will remove that. Don't worry, we will deal with that. right? Similarly, there is second phenomenon known as underfitting. And these are interview questions. Whenever you give an interview on the machine learning, they will ask you these questions: overfitting and underfitting. Okay. So when my performance is good on the training data, but bad on the test data, this is known as overfitting. You are learning from the training data, right? Underfitting. Your performance on the training data is bad. And even your performance on test data is also bad. Right? This is also bad. Means what? This is what? This is like Chatur. Okay. And this is like, even you can call it as the friends of Amir Khan in that movie. I do forget the name. Was getting last number from everywhere. You're not good even on the training data, not even good on the test data. You don't learn even the pattern what is being taught in the class. Right? Getting the point, everyone? Okay. So when your performance is bad on the training data, even on the test data, it is known as underfitting. Means forget about the unseen data. You are not even performing on the training data. Okay, at least from this purpose, your performing the training data is good. It is at least learn the model. It is not learning even. So training data performance is bad. Even the test data performance is bad. But what kind of model we should? Underfitting and overfitting? No, neither this, neither this. We should choose a model known as generalized model. Generalized means whether it's a training data or it's a test data, on both performance should be good. Good performance on this, good performance on this. Okay, this kind of model we need, known as generalized model. And decision tree algorithm has a drawback. It's prone to overfitting. It's prone to overfit, but we can control that. Okay, we can control that. So how can we control that? Let me show you that. Let me show you a small glimpse. Okay, what is a small glimpse? See, what is my training accuracy, everyone, right now? Sorry, training accuracy is 98%, and test accuracy is what? 73%. Let me come back. Okay, let me create a new model, model 1. Okay, and let me put a parameter here, max depth, which is there already. Max depth. Okay, by default it is, see, nothing should be mentioned. None means go as much as deep you can in your tree. Means first node, then second node, then third node, then fourth node, then 5 node, then 6th node. Mean go until your there is no ambiguity in the decision. Okay, or every data point is split. Means go until there is no ambiguity, or every data point is split. This is what max depth is equal to none means. But I'm controlling that. No. Do one thing. Only go till depth of 2. I just mentioned here example 3. Example. Depth of 3. Example I just mentioned here. Okay. And let me execute this. Okay. Means don't go till deeper, means till every data point is split, or don't wait till no confusion is there. Okay. Means there is no ambiguity in the making the decision. Okay. You have to stop at the maximum depth to be 3. Okay. I just make max depth is equal to 3. Let me make it model 1 dot fit. Again. Okay. And again, model 1 dot predict. Okay. And that is fine. That is fine. Everything is fine. Let me check this time. Can you see, everyone? Please check the test accuracy.
80%.
Right? How much improvement? 7% improvement we have just done. Right? And come here. Check your test accuracy. Model 1 dot predict. This will dip because you are not giving a chance to bug up everything. Right? That's why. So even this will decrease this time. See, it decreased because you didn't allow it to learn everything. You didn't allow it to learn everything. You said, okay, you have to stop once the depth of the tree is 3. You don't allow to go other again. If you don't allow, remember, it will keep building the tree, like this. First node, second node, third node, fourth node. It will keep doing that. Okay, like this. Root node, then further node, then further node, something like that. Then further node, example, then further node. Okay, then further node, something like this. Till you are in condition that you can give a decision which is not any ambiguity. Directly we have only positive class or negative class, something like here only 4 positive, 0 negative, here 2 negative, 0 positive, something like either this, or your every data point is split, every data point is separate like this. Okay, when it is the case, of course it will learn everything. So you're controlling, no, your depth is not allowed beyond 3. You are not allowed to go. So you stop here. So further stepping will not happen. You're not giving him chance to what? Learn everything. You stop that. Okay, that's why the performance is not learning, so he's understanding the concept. Okay, I'm not learning everything. That's why your training accuracy dipped, but at the same time your testing accuracy is dipped, but they are very closer to each other. Can you observe, everyone? Earlier difference was too huge, 25% difference is there. Now difference is less. Even both are near 80%. Now this model is better in comparison to previous model. But we were seeing 73% was the test accuracy and 98% was training accuracy. Only training accuracy is no use, bigger, third class. Okay, but 80 and 83, these are at least closer. Even you can make it increase further by putting several hyperparameters. That's what I told you. Whenever you are dealing with machine learning algorithm, please go to the hyperparameter section of every tip, go to the scikit-learn and see an experiment and play. Okay, I put max step is equal to 3 only. Okay, you can play with it again. Okay, no, you can do this thing. Okay, this is giving me 80%. Let me try this thing. Okay, let me come back again. And instead of 3, let me make it 2. Okay, and model 2, suppose model 2. Let me execute this. Done, done, 2, done, done. See, it dipped. So 2 is not of your use, right? Model 2 and come. Not helping us out, right? It dipped. So which is better? 3. You can try even one more. Let's check. This one, 3, again 4. Model 3, model 3. Model 3. Okay, done. Accuracy score 80%, right? Good. Let's check this. Okay, this. So we can play with that. Even manually, I'm changing. No need of doing that. No need of doing that. You can make it a function out of this. How? Simple like this. You can create a list. Suppose max depth equals to, although there is a function available, I'll show you that function known as grid search. With the help of that, you can just put the parameters and automatically will do the computation. But if you ask me personally, I prefer my own instinct and do that way. For example, I can create a list like depth of 2, 3, 4, 5, 6, 7. I will check. Okay. Then I will say for depth in my depth, max depth. Okay. Colon. What? Come here. Pick it this. Pick the line, which is that this one. Right? You can put this model, whatever it is, instead of putting it 4, what I should put here, this, because this is what I'm iterating over this list. Okay, so in every iteration, this depth will have one value of this. In first iteration, 2, second iteration, 3, fourth iteration, 4, fifth iteration, fifth, sixth iteration, 6, seventh iteration, 7, and let me get an empty list, suppose accuracy list, which is an empty for now. Right? So what I can do, I can iterate over this 1. So in first iteration, this will become, if I let me put it here, depth, this loop variable. So in first iteration, it will become what? 2. So you will model will be taking the depth is equal to 2. Then you can say what? Second parameter, that is model dot. Where is this? Where is model dot fit like this? Okay. Then what you can do? Again, same process. You can do this. Wipe red. Okay. Then you can do what? After prediction, what do you have to do? You have to calculate accuracy score. Okay. And suppose this accuracy score I will save in some variable, suppose A. Then what I can do? I can do one thing. After calculating this accuracy, whatever result is coming, okay, for 2, I will append in this list. So I can say accuracy dot append. Okay, and in this I can pass what? A. Okay, so in first iteration, depth will become 2. Okay, it will calculate your, it will train your model on the depth of this equal to 2. Your accuracy will be calculated. Whatever accuracy is coming will be saved inside this. In next iteration, your max depth will become 3. And it will go and again you can go until how many points will be checked? 1, 2, 3, 4, 5, 6, 7. And then you will be able to use them. Getting idea, everyone? How can we use that? Please tell me. And this thing should come to your brain automatically. Nobody is going to tell you these things should come. Whatever, tell me, any rocket science I put it here, any rocket science or anything that you have not learned. right? So from looking at this accuracy, you can easily tell, okay, which one will give me the best result. I'm just giving the 4 parameters. You can put any money as you can. It's your choice. Okay. Or instead of max depth, you want to try for every combination to loop this. Okay. You can mention this for depth in range, right? You want to try. Suppose I want to try from 2 to 50. That's try an experiment. What result you will get? Getting idea, everyone? Please tell me. I'm waiting for answers, everyone. Nobody's saying anything. Everyone, I'm waiting. Clear what I've written or not? At least say yes or no. I will get an idea. Okay, this one, this see what we did here. Understand what we mentioned here, max depth is equal to 4. It's a parameter, right? So what I did, once I experimented by putting 2, then I put it 3, then I put it 4, then I computed an accuracy again and again, okay? But this is the manual work I'm doing right now, right? This is the manual work that I'm doing. So why we are doing manual? We have to change it 1, 2, 3, 4. So why don't I check it? Whatever parameter I want to put in the max depth, okay, I can put in a list. Example, this max depth is equal to whatever name you want, parameter you want to put, 2, 3, 4, 5, 6, 7, 8, like this, okay? And you can iterate over this. You can iterate over this, right? You can iterate over this. So instead of this, you can mention here your max depth, right? So what will happen in how many times this loop is going to run? I want to mention for depth and max depth. How many elements are there? 1, 2, 3, 4, 5, 6, 7. So this loop is going to run for how many times? 7 times. Okay. In every right, in every iteration, what depth will have? Depth will have value equals to one element of this. In first iteration, depth will have the value what? 2. Right. So now what? See what is the next statement? Model 3 is equal to decision tree classifier. Same formula I've copied. Max depth is equal to depth. What is the depth? In first iteration, everyone, what is the value of depth? 2. Right. So my model will be trained on the depth is equal to 2. Okay, and I will compute the corresponding accuracy, and whatever accuracy is coming, we will store that inside this accuracy by using accuracy.append. Is next means in first element, what will happen? The result corresponding to depth is equal to 2 will come in the accuracy. In second, what will happen? Remember 3. So second situation, what will be the value of depth? 3, right? So your model will be trained. Depth will become what, everyone, this time? 3. So now your model will be trained on the depth is equal to 3. Your accuracy will come. That accuracy will store in the second element. Again, same. So you have now 2 accuracy, one corresponding to 3. Then what you will do? You will move ahead, and what is this? 4. So in third iteration, depth value will be what? 4. So 4 will go here. So now your model will be trained with the depth is equal to 4. Okay, you will get some accuracy. The accuracy will be appended where? In this list, and then you can check which is giving you maximum value. Accordingly, corresponding depth parameter you can put in your final algorithm like this. This is what we did. We just did hyperparameter tuning. Get now, Varun and others, please tell me. Everyone, tell me, is it okay?
Yes,
Again,
sir.
okay. But see, this is actually, I'm just telling you, when one parameter needs to be trained, sometime you may need to train 5 to 6 parameter. Again, doing this thing again and again will take so much time. So luckily, we have a function for the same that we will discuss, known as grid search. We can create a grid of the parameters that we want to tune. Okay, in only one code, multiple parameters can be tuned at the same time. We will see that, don't worry. Okay, but I will tell you that don't rely only on the basic method, or don't rely on the inbuilt method. You can generate method of your own. Even you can create a function of these. Okay, you can create a function out of this for hyperparameter tuning. Don't rely on the even different function. You know that you can create a function of this which will accept a parameter from you, what parameter you are passing inside. Accordingly, you can do that. Very, very simple way. You can pack that inside a function as well. Very, very simple way. And use it as per your requirement. Right? For example, what I can do this thing. Def a function name is hyperparameter. Okay, which will accept one parameter, right? Then I mention here, I created what? An accuracy, an empty list. Okay. Then I mention for, I know that I have to pass a list here. So you mention here for, same thing, same, exactly copy this thing inside. Like this. Okay. So list will be done. In the last, what you can do, you can return your accuracy. Once it is done, you can return your accuracy. Getting the point, everyone? So how quickly one hyperparameter, and your next time you are to go and call it, just call it like this, hyperparameter. Okay, hyperparameter, and within that pass your list like this, 2, 3, 4, 5, 6, 7, and everything will be done in one go. Yeah, right. So things are basics, very, 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 very simple. No, 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 no. Why loop will run till we achieve 95? No, loop is not dependent on that. Loop will run only that many times, that many elements that you have put. Loop will run only for that many times, that many number of elements we have put. Loop runs, remember, that many elements, that element we will put. Only that many times it will run. We have put a limit now. How the loop runs? What is the for loop? For loop runs when you know how many times you have to run a loop. You have to run a loop for a fixed number of times. That when we go for the for loop, and we set that max depth here. So how many iterations it will have? 1, 2, 3, 4, 5, 6, 7. So 7 iteration it is going to work only. Only on 7 iteration. Got it, Varun? Yeah, anything, your choice. Anything, your choice. In that case, you have to put whenever loop is your every element has been done, you have to get it out of the loop. But normally, what we use while. Remember, what is the purpose of the while? When we want our loop to run till a condition is true. Okay. When for a fixed number of times you want to run the loop, which is better? Your for loop is better. Of course, you can do same thing with the help of while as well. But better is what? Go with, in this case, go with the for loop. Got it, everyone? Yeah, remember that. Okay. These are simple basics, but I told you what we can do. Okay, so let's come here back again. So what I was telling you. Okay, so we saw that. Okay, by changing the value of max depth, we change the parameter. Okay, how much your depth will grow. There's one more parameter. Several parameters are there, but let me tell you one important one. This is your min sample split. Come on, come on. Yeah. Not here. Sorry, what I was doing. Min sample split. Okay, what is this parameter? See, go here and read. Minimum number of samples required to split an internal load. Minimum number of samples required to split an internal load. What do you mean by that? Okay, understand. Come here, everyone, and let me show you that. I'll pick it up like this. See, I put suppose this parameter min sample split is equal to, let's say, 4. Okay, I put minimum sample split is equal to 4. And suppose I come at the root node. At root node, when I came, I had 20 leaves, 20 samples available. Okay, so it will check. Okay, it is a root node. Minimum samples to required to split is what? 4. It is way more than that. Suppose it's split it in 2 parts. Okay, based on a criteria. Based on a criteria, maybe suppose humidity, then it will be a high or low. Example, high and low. Example, something like that. Okay, I'm just giving an example. And something like here we have 12 samples out of 20. Here we have 8 samples. So again, it will split depending upon check how many samples are there. How many is the condition? Minimum sample split is what? 4. If it is less than or equal to 4, then sorry, it is less than 4, then you cannot split. Minimum samples to split is 4. It is what? 12. So of course we can split. Suppose further I split it something like this. 8 and 4. Okay. And suppose it is split it in 2 and 6. Further. Okay. 2 and 6. Now further, everyone. Here we came. 8 is again what? Greater than 4. It can further split. Suppose like this. Suppose it came across 4 across 4. Right? So it is again 4. So it can further split. Suppose 3 across 1. So can we split these nodes further? No. Because minimum number of samples required to split is what? 4. Now it has become what? 3. So it cannot be splitted further. It cannot be split further. That means you are controlling the depth now. Here it is 4. So it can split. Suppose 2 and 2. So will it split, everyone? Tell me. If 2 and 2 samples are there, what is the minimum condition to split is? 4 samples should be there, but how many samples are remaining? 2 and 2. So will they split? No. So they will not further split. Come here, 4. 4 is there. Okay, so it can split because minimum condition is 4. So suppose they split into 1 and 3. So will they split? Everyone tell me. Will the further tree grow down in case of this node? Very
No.
good one, right? Very good. Now tell me, will it grow? This will 2 will further split it,
No, it will not.
but this 6,
It will.
it can, right? It can. Suppose 2 and 4. So can it again? No. But it can? Yes, it can, right? So 1 and suppose 3. So now further it will not split. Okay. So with the, you can control the depth of your tree again with the help of a parameter known as min sample split. And you can experiment. You never know what is the correct result. So you have to experiment. What? Check for 2, check for 3, check for 4, check for 5, check for 6, check for 7. For which hyperparameter I will get the correct result. This is nothing but known as your hyperparameter tuning. Okay. This is known as hyperparameter tuning of machine learning algorithms. Right? Hyperparameter tuning of machine learning algorithm. Every machine learning algorithm has some hyperparameter. Remember in KNN, we have a hyperparameter what? What was the hyperparameter? Remember? Numbers, neighbors. How many neighbors are there? You want to choose 5, 7, 9, 11. So you can check for 5 how much result I am getting, 7 how much result I am getting, 9 how much result I am getting, 11 how much result I am getting. Right, everyone? Right? So this is nothing but hyperparameter tuning. So whenever you are picking any machine learning algorithm, go there, okay, and check your hyperparameters. And how will you check? Okay, always go into the sklearn side, or even better than that. If you are not comfortable in that, go to the Google and just type example hyperparameter tuning of this machine learning algorithm. You will 100% find an article. Click on that and change your parameter as per them at the beginning stage, when you are growing your career in the machine learning at the, because you cannot become expert in the beginning itself. Okay, when you spend at least 100 hours, 200 hours on the machine learning, then you will become comfortable. You no need to see anywhere. You directly type done. This parameter is there, this parameter is there, this value I will try, this value I should try. But at the beginning stage, everyone learns this way only. First, tell me, everyone clear what is the top, what is the mean by hyperparameter tuning? Tuning the parameters of your machine learning model, okay, is nothing but your hyper parameter tuning. For different parameter, we saw that we are getting different result, and we can do with the help of for loop that we just saw. But don't worry, we have a separate function for the same. I'll tell you that. Don't worry about that. But is it okay if you went so far? Now tell me. I'm waiting for the answers, everyone. And if you're stuck somewhere, just tell me, sir, here we are stuck. No problem. I don't mind in explaining again. At least say yes or no. I'll come to know what you people are getting scared of. Hardik, are you there? I'm not able to hear his voice. Hardik, are you there? Oh, he's not there, I think. Okay. Varun, Swati ma'am, others, please. Any doubt? Anyone? Please say yes or no. At least come to know. I'll come to know that you are understanding or not. Okay, fine, perfect, perfect. Okay, now let me move ahead. Okay, and let's see other parameters. That's fine, whatever we have done. See, accuracy. I told you there are other parameters as well, as I told you. What are those? Let me come here. Okay, and use them. What is those? Suppose I said here confusion matrix. Okay, what it needs a parameter? It needs again same two parameters: y true and y predicted. True and pred. So I mention here true. So suppose I'm testing for the test. So I mention y underscore test is my true value, and y pred is my predicted value. Okay, I execute this. I get a confusion matrix. What is this confusion matrix is all about? See, everyone, this is important. Okay, so we're getting a sort of array here. But what it is, see, suppose here I make a matrix, something like this. And here we have actual values. Okay, and here we have predicted values. Okay, so we have two class here, 0 and 1 class. So suppose I'm calling one class to be positive class, one class to be negative class. Let's say for example. Okay, one to be positive, one to be negative. Okay, so I'm mentioning here positive, mentioning here negative. Similarly, I'm mentioning here positive, I'm mentioning here negative. Now see everyone, how will you read it? How will you read it? That is very, very important. Okay, but remember, some of the websites or books you will refer, they can take your predicted value on this side and actual value on this side. Okay, but remember your actual point that you should consider. I'll tell you that. Just a second. Just give me a second. Okay, understand how we should read it. See, in this side we are getting predicted values. In this side we are getting actual values. See, so what is this? What this first cell is representing? See, first cell is representing that your actual value predicted by, your actual value of the class is positive. Okay, and your machine learning algorithm is also predicting what? Positive. Means they are matching. They are matching. Your actual class is positive, and your machine learning model is also saying yes, it is positive. This thing we call it as true positive or TP. It is positive, right? In actual, it is positive, and machine learning algorithm is also assuming it, also predicting as what positive. This is known as true positive. Okay. Now come here. Your actual value is negative. Okay. Your actual value is negative, and your machine learning model is also predicting negative. Machine learning model is also predicting negative. This is known as true negative. Means it is a negative class, and machine learning model is also saying yes, it should be negative. So this is your true negative. Okay. And this is actually your correct results. So diagonally, you will see your correct results. So these are your correct predictions. These one. Okay. These are your correct predictions. Now come here. This one. See, your actual value is negative. Actual value is negative, but your machine learning model is saying what? It should be positive. Okay. Means machine learning model is predicted as positive. Your actual is negative, but machine learning is predicting is positive. So it's a correct positive or wrong positive, everyone? Actually, it is negative, but machine learning model is saying no, it should be positive. So it is what? Correct positive or wrong prediction it is done. Actual is negative, but machine learning model is saying negative. Sorry, actual is negative, machine learning model is saying it is positive. So it's a correct prediction or wrong prediction? Wrong, right? So what machine learning model is predicting? Positive, but it is wrong. So we'll call it as false positive or FP. We'll call it as false positive or FP. False positive or FP. Similarly, come here, everyone. Take here. Okay. Your machine learning model is saying what? Actual value, sorry, your actual value is what? Positive. Okay. Actual value is coming from here, positive. But your machine learning model is saying, no, it should be negative. Okay. So the prediction by machine learning model is again wrong. It is saying negative. Okay. Negative. But is it a true positive? No, it's what? False negative, because your actual value is positive, but machine learning model is saying negative, right? Prediction is negative. So this negative is wrong. Whenever it is wrong, what we will say? False. That's why you mention here what? False. And this positive and negative are coming as per the prediction by the machine learning model. If machine learning model is saying positive, we'll mark it positive. Okay. Now true and false depends upon when your true and predicted values are matching. See, machine learning model is saying what? Positive. So we'll mention positive here as well, here as well. Let me draw it once again. Okay, just a second. Just a second. Quickly. Like this. Okay. This is your true result, actual results. And here are your positive, actual positive. Okay. So in this particular column, all the positive values are there, actual positive values. Okay. Here, negative, but actual negative. So in this particular column, actual negative. Here, positive, but prediction by machine learning model. Predicted. Right? Here, negative. Okay. So what my machine learning model is saying positive. So we'll mention positive. No problem. Here also it is positive. Here machine learning model is saying negative. So I will put a negative. Now verify everyone. Prediction is saying positive. Actual is also what? See above. Actual is also what? Positive. So both are matching. So we'll say that true positive. Perfect. Okay. Now see. Prediction is saying positive, but actual what? It is negative. Prediction is saying positive, but actually it is what? Negative. So this positive will be known as false positive. Right? Getting idea, everyone? As simple as that, right? Similarly, here it is model is saying negative, but actual is what? Positive. Actual is what? Positive. So this is wrong. So what will you say here? False negative. Right? We'll call it as false negative. Now come here, everyone. What is this negative? What is this negative? Your machine learning model is saying negative, and in actual, what it is? Also negative. It is also negative, right? So both are matching. What will you call it as? True negative. Okay. So true positive, true negative are your correct predictions. So diagonal, whatever you are seeing, these are your true predictions. Okay, or actual prediction means correct predictions. These are diagonal one. Clear, everyone? Now tell me. Fine. What is the confusion matrix and what you are seeing here? I'm waiting. Please, everyone, tell me. Okay, Varun. Great. Awesome. Thanks, ma'am. Thank you. Very good. Awesome. Perfect. Thank you again. Thank you, sir. Very good. Right now, move ahead now. Okay, further. So confusion matrix, we understand what it is, right? Now there are other parameters as well. Okay, remember precision and recall. What is that? Precision and recall. Understand them very well, everyone. Precision and recall are the two parameters. Okay, understand. Suppose what is happening, I have a class. I have two classes, positive class and negative class. Okay, two classes are there. In positive class, I have 300 data points, let's say. Okay, out of 300 data points, your machine learning model predicted correctly that 200 belongs to this positive class only. 200 belong to this positive class. It said that. Okay. So what we will do, we'll put here 200. Understand, everyone? 300 total data points are there. In total 300 data points are there, out of which it correctly predicted that these 300 data points, out of these 300, 200 belongs to this class. Okay, 200 belong to this class and 100 belong to different class. Take it this way, everyone. 100 belong to 200 belong to this class, positive class, and 100 belong to negative class. In total, in positive class, I have 300 points, but my model said, understand, that's very important what I'm saying. Understand, everyone? Out of this 300, my model predicted 200 are positive. Okay, which are correct. Out of these only, because 300 were positive, but my model predicted 200 are positive out of these. Okay, and 100 are negative. Fine. But these, of course, these predictions are wrong. We know that. No problem. Now come here. We have negative class. Again, suppose we have a 300 points there of the negative class. Okay. And out of this 300 negative class, again, suppose it predicted, let's say 200 belong to negative class. Means correct predictions. Okay. And 100 belong to positive class, means wrong predictions. Something like this. Okay. 100 belongs to positive class, which is a wrong prediction. So what is the precision? Understand, I'm writing here, everyone see properly. Precision is equals to what precision says. We will calculate it for every class, right? But it is that true positive upon true positive plus false positive. See, everyone, that's very, very important what I'm saying. True positive upon true positive plus false positive. What do you mean by that? Okay. As I told you, I'm repeating once again, everything, see properly, everyone. True positive upon true positive plus false positive. Okay. So means if I have a positive class, okay, I have a positive class and my machine learning model predicted that there are 300 points which are positive class. 300 points belongs to positive class. But out of these 300 positive points, actually, understand, actually only 200 are belongs to positive class. My machine learning model has predicted 300 to be positive class. Okay, it has predicted that 300 points are positive class. Okay, but in actual, out of these 300, only 200 are actual positive class. Okay, so these which are actual positive class will be known as your true positive. Like this. So you mentioned true positive upon true positive plus. Okay, and rest 100, remember, out of 300, Total 300 belongs that it belongs to this positive class. 200 actually belongs to positive class. So this becomes true positive. And rest 100 actually belongs to negative class. But my model has predicted that they belong to which class? Positive class. Okay. They belong to negative class. My model has predicted they belong to positive class. So such data points which belong to negative class, but my model has believed that they belong to positive class, will be known as false positives. Okay. So we mentioned this one, false positive. So out of the all predicted positive, how many are actual true positives? This is nothing but your precision. Clear, everyone? Please see and tell me. Take your time and tell me. No issue. Please take your time and understand what it is telling me. I repeat once again, entire process. Please see. Actually, it is important. That's why I'm emphasizing again and again, again and again, again and again. This precision and recall are more important than your accuracy score. Especially when your data set is imbalanced. Means in positive class and negative class, you don't have same number of data points. In that case, what is important? I repeat once again, in case of imbalanced data, suppose I have two classes, na, 0 and 1. One class I have 400 points, okay, and one class has 200 points. So these are imbalanced data. In that imbalanced data, your accuracy is a very bad matrix. Very, very bad matrix. Let me give an example. Suppose I have a highly imbalanced data in which I have 980 rows corresponding to positive class. Okay. And only 20 rows corresponding to negative class. Right. And what happens, understand? I train my model. And my model is giving me 98% accuracy. What you will say, model is very good, 98% accuracy. So what is happening? It has learned everything from these positive points, but because negative points were very less, so it could not learn. Even what is assumed, even these 20 points, when we will pass inside my machine learning model, it will also predict them to be positive only. It will also predict them to be what? Positive only, because my machine learning model has learned large on which are huge in number for the training, this data set. Okay, so my machine learning model will learn, okay, 980 points are positive, 20 are negative. I will assume that, okay, even these 20 points belong to positive points. Okay, so how much accuracy I'm achieving? 98%. Everything seems very good. Wow, 98% accuracy. What happened? If you see properly, this model will predict fine correctly. These 980 rows, it will predict correctly. But whenever these 20 points will be passed to them, it will also assume that they will be also positive. Okay, so accuracy seems 98%, but these 20 points, all the time they have assigned them what? Positive, which is negative. That means what? Your model is a third class model. Although your accuracy is 98%. Okay, although your accuracy is 98%, but it is never able to predict this class. It is never able to predict this class. So what model is this? Is third class model. In such cases, actually precision and recall become very, very important and very common interview question. When my data set is imbalanced, which matrices you will use? Okay, accuracy is 98%, but right, is it able to predict this class, everyone? No, because very less data points are there. It is always perform well on which more data points are there. So accuracy is 98%, but it is not able to predict these 20 points. Right? So performance is good on positive, but not on good on negative. Seems like 98% model, but it is not able to predict these 20 points. My model is very bad. Imbalanced data. In such imbalanced data, what metrics you should use? You should use precision and recall. Very common interview question. In case of imbalanced data, which matrices you will use? That will be your precision and recall. So I'm repeating once again, precision, everyone, and precision and recall. Important, everyone. Very C. Sorry. Let me again click on the same. Give me 5 minutes more. Okay, only 5 minutes. See, suppose I have two classes. Okay, suppose males and females. Okay, and my model predicted what? Predicted I have 300 males. My model predicted that 300 are males. Okay, 300 are males, but actually, out of the prediction that machine learning model has done, only 250 are the males. Okay, in my data set, I have two categories, males and females. Okay, and my machine learning model was trained. Then what I predicted that actually 300 are males. But when I analyze it properly, I understand, no, 300 are not males. Actually, this is a prediction by the model. Okay, but actually 250 are only males. Okay, so whatever prediction it is, only 250 are correct. So whatever is correct, we will call them as true positive. We'll call it as true positive. And rest, when 250 are correct, that means rest 50 are incorrect. Okay, if 250 are correct, that means rest 50 are incorrect. This we will call it as false positive. This we will call it as false positive. So what is my recall? Recall is nothing but true positive upon true positive plus false positive. This is your precision. Okay, so precision is what? True positive upon true positive plus false positive. Clear, everyone? So out of the total positive predictions, how many are actual true positives? How many are actually positive? Okay, example take place. You conducted a COVID test. In COVID test, 300 people came to you. Okay, or 500 people came to you for the COVID test. Okay, your machine learning model predicted 300 are having COVID test, or 300 are having COVID positive. Okay, but out of this 300 positive COVIDs, only actually 200 were COVID positive. Okay, rest machine learning, your model predicted wrong. Your test predicted wrong. Okay, so these 200 are true, right? They are COVID positive. So these will become true positive. And rest 100 will become what? False positive. Right or wrong, everyone? Tell me. Clear? Tell me, everyone. Right? Because your model predicted 300 to be positive, but actually only 200 were positive. So they will be true positive. Okay. Okay. 200 are true positive and rest 100 are what? False positive, which your model has predicted. So those will be known as false positive. Okay. So your precision will be what? True positive upon true positive plus false positive. Clear? Right? Similarly, everyone, we have recall. What is recall? Now you can understand itself. Recall is what? True positive upon true positive plus false negative. Okay. True positive upon true positive plus false negative. What do you mean by that? Suppose, again, we have two classes, males and females. Or let me pick a COVID case only. Okay. Suppose 500 people came. Out of 500, 300 were COVID positive. Okay. They were positive. But your model predicted only 200 to be, your model predicted 200 to be COVID positive. Okay. And rest 100 to be COVID negative. But actually they were positive. But your model predicted what? Them negative. Okay. So what is my true positive? My true positive is 200. Fine. That is 200. Okay. Again 200. But they also what? Actually these 100 should also be what? Positive, because 300 were COVID positive. But what you have assumed them? Negative. What you have assumed them? Negative. So these are what? False negative. Actually they should belong to positive class, but you have marked them as what? Negative. So they will be known as what? False negative. So this becomes your 200 plus false negative. False negative is what? Your 100. So it becomes your 200 upon 200 plus 100, like this. So true positive upon true positive plus false negative. I'm repeating once again. 500 people came for the test, out of which 300 actually were COVID positive. Okay. But when you conducted the test, your test found that 200 are positive. Out of these 300, okay, I repeating once again, out of the actual positive, 300 are positive and 100 are negative. Okay. So which it is predicting correctly will be known as true positive. Because they are positive, it's predicting positive, and 100 is predicting no, they are not COVID positive. So they understood that it is COVID negative. Okay. So actually they are positive, but your model is predicting them negative. So they are what? False negative. Right or wrong, everyone? Actually they are positive, but it is predicting what? Negative. So what it will be? False negative. So recall is what? Nothing but true positive upon true positive plus false negative. Clear, everyone? Right? It should be clear. Now in one line, actually, we can achieve this requirement by using, see what, I will just write one command and I will get every information like this. See what? I set classification report. It will show me precision and recall of every class. Classification report. Okay. But it needs again true and predicted. See inside true and predicted. What is true? True is y underscore test. Okay. And what is predicted? Predicted is y pred. Okay, and let me put it inside the print statement to see it properly. It will show you precision, recall, everything of every class. Execute this. Can you see everyone? It is showing me for zero class. What is the precision? 0.80. For one class, 0.80. Okay. Recall is better for which class? Zeroth class, but not good for one class. Okay. There is one more score known as F1 score. What is that F1 score? F1 score is nothing but this one. Okay. It's a representation of both the values, precision and recall. F1 score is nothing but 2 into true positive into false positive. Sorry. 2 into precision into recall upon precision plus recall. Okay, means 2 into precision into recall upon precision plus recall. This is nothing but your F1 score. Okay, so it's a representation of both the precision and recall. The model which is having high F1 score is a very good model, right? So it's a representation of 2 into precision into recall upon precision plus recall. Clear, everyone? Please tell me. And you can compute this. You can catch this. What is the 0.8? 2 into 0.8 into 0.9 upon 0.8 plus 0.9. What it will be, everyone? If we do this, I think we will get 2 into 0.72 upon 1.7. Okay, so it will become, I think, 1.4. 0.72 into 4 will be 1.4 divided by 1.7. If I calculate with the calculator, 1.4 divided by 7, 1.4 divided by, oh, what happened? 1.4 divided by 1.7. Okay, so we are getting some results. Okay, I think we are doing some correct. Yes, 0.8 into 0.9, everything should be fine. Let me check the formula. I think formula is correct. Just a second. Google recall formula. No, not recall. A formula of F1 score. Yeah, it's fine. 2 into precision into recall upon precision plus recall. Same formula is there. Let me check on the images as well. Yes, same. 2 into precision into recall upon precision plus recall. Okay, this is the formula that we are discussing. 2 into precision into recall upon precision plus recall. Same formula is there, right? So you can see from this where we are dealing, you are individually 0th class precision, 1th class precision, 0 class recall, 1 class recall. Okay, and 0th class F1 score and 1 class F1 score. Okay, this is the better matrix. So where we should use precision and recall, especially in those cases where your data set is imbalanced. Clear, everyone? Fine. Please tell me. Okay, so I'm ending for the day. I will continue tomorrow, everyone. Okay. Okay, Varun. Bye bye. Take care. Bye bye.